Hi folks. The next skill we need to learn in this unit is how to determine how much of an element there is in a particular compound in terms of its mass. And this is called percent composition. It's the percent by mass of each element in a compound. Whenever you calculate a percent is always part divided by the whole times 100. We multiply by 100 because percent means out of 100. So all percentages always involve multiplying by 100. In this case, the part divided by the whole, the part is the mass of the element in the compound, and the whole is the total mass of the entire compound. So these numbers, the mass of the element, we get that by looking at the element's molar mass and multiplying by the subscript in the formula, multiplying by however many atoms of that element we actually have in the formula. The total mass is just the compound's molar mass, as we've learned to calculate already. After you do the percent composition for one element, you repeat that procedure for every element in the compound. So let's look at a simple example to start. Here is copper 1 sulfide, and we want to calculate the percent composition for copper 1 sulfide. In this formula, we have 2 copper atoms, so when I want to figure out the percent composition with regards to copper, I need to remember that I've got 2 atoms of copper. I get the number 63.55 off the periodic table, and the molar mass of the entire copper 1 sulfide compound is 159.17 grams. The part divided by the whole, don't forget to multiply times 100. And the answer that we get is 79.85% for the copper. Let's do the calculation for sulfur now. We only have 1 atom of sulfur because there's no subscript next to sulfur, so I don't have to multiply this times anything. I just use the value off the periodic table, 32.07. But I divide by the same total molar mass because copper 1 sulfide has a molar mass of 159.17. Multiplying by 100 gives us a value of 20.15% composition for sulfur. Notice that if you add these two values together, they should and do add up to 100%. Let's do another example. Find the percent composition of potassium nitrate. In potassium nitrate, we have 1 potassium atom, we have 1 nitrogen atom, but we have 3 oxygen atoms. So we're going to have to take that into account when we calculate the entire molar mass, as well as during the percent composition. Looking at the periodic table, my molar mass for potassium is 39.10. For nitrogen, it's 14.01. And for oxygen, it is 16.00. Doing my multiplication, my value for potassium doesn't change. My value for nitrogen does not change. But I do not need to multiply my oxygen value times 3, and that gives me 48.00. When I add up all of these values, I get an answer of 101.11 grams per mole. But now I can use these values to determine the percent composition. I know my total mass of potassium, my total mass of nitrogen, my total mass of oxygen, and I know the total mass of the entire compound. So to find the percent composition of potassium, I just need to take the mass that is potassium divided by the total mass and multiply times 100. And that gives me a value of 38.67% potassium. I can follow the same procedure to figure out the percent composition of nitrogen. 14.01 divided by 101.11 times 100 gives me a percent composition of 13.86% nitrogen. For oxygen, I do 48 divided by 101.11 times 100, and that gives me a percent composition of 47.47% oxygen. So now I know if I have potassium nitrate It is always 38.67% potassium, 13.86% nitrogen, 47.47% oxygen. Again, as before, my percentages add up to 100%. Let's do one last example. Find the percent composition of aluminum sulfate. This is a little more complicated to keep track of how many of each atom we have, so just make sure that you can figure this out correctly. I have 2 atoms of aluminum. I have 3 whole sulfate ions, which means I have 3 times 1 is 3 sulfur atoms. And I have 3 times 4 is 12 oxygen atoms. That's important for determining the mass. According to the periodic table, the molar mass of aluminum is 26.98. For sulfur, it is 32.07. And for oxygen, we have 16.00. Doing all of my multiplications, because I have 2 atoms of aluminum, 53.96. Because I have 3 atoms of sulfur, I have 96.21 grams per mole total of sulfur. And 12 times 16 is 192.00 grams of oxygen. Adding all of those values together gives me a total molar mass of 342.17. So how do I determine percent composition? Part divided by the whole times 100. The part that's aluminum divided by the whole mass of the whole compound times 100. And that gives me a percentage of 15.77% aluminum. For sulfur, the part divided by the whole times 100 gives me a percent composition of 28.12% sulfur. And lastly, the percent composition of oxygen, I've got the part divided by the whole times 100. Now in this case, I had 4 sig figs here and 4 sig figs here, which is why I gave 4 sig figs in my final percent. But here I've got 5 sig figs divided by 5 sig figs. So my answer should be reported to 5 sig figs for oxygen. Again, to check, all of my percentages should add up to 100%. This time, I'm slightly off, though, with my percentages, or I look slightly off, but if you look, actually, due to the rules of addition, if I only go to 2 decimal places, I can only go to 2 decimal places in my answer. However, it's okay if your percentages don't exactly add up to 100%, because due to rounding, sometimes they're off by 1/100 of a percent or so. So just to summarize that checking calculations procedure, if you add all of the percent compositions for the elements in your compound, they should equal approximately 100%. If they aren't exactly 100%, that's okay. Sometimes due to rounding, your values will be slightly off. I hope this helped.